Good morning, everyone. Super exciting to be back in the chair. For those of you that don't know, I am Rob Petrosino, Synth Rob on Twitter, running the Synth Reality podcast, tech executive who's focused pretty much exclusively on emerging technologies and its implementation in corporate customers. Last time around, we talked quickly about ChatGPT and how it impacted the retail. Threw some clips up on Twitch, but also on YouTube live podcasting. So, pretty excited about today's show. What we're going to talk about is a couple different things, but mostly talking about digital twins. For those of you who don't know about digital twins or never heard of digital twins before, you are going to be in for a pretty crazy ride. I will tell you that much. Digital twins are fascinating. They're really, really interesting when it comes to how they're being deployed in organizations right now, what they do, and what they look like, and what they can do as far as efficiency drivers. Before we get too deep, though, we're going to just chat a little bit about what a digital twin is and how we define it within the industry. So, a digital twin is pretty easy to think of, or pretty easy as far as its top level ideation, but as you get deeper, it gets a lot more complex. So, digital twin is a digital representation of a real world object. It could be any object underneath the sun. It could be a chair, it could be an airport, it could be anything as complex as a Formula One race car, all the way down to the most simple object like a chair. So, the level of technology related to that digital twin obviously make it more complex, but when we think of a digital twin overall, it is just the replication of something, someone, anything in the physical world that is then replicated into the digital world. Now, that is layer one of a digital twin. Layer two of a digital twin is data. We're going to put that aside for the second and just focus on this visualization aspect. So, a visual representation of a chair, airport, plane, bus, set of dice, a phone, doesn't matter. That visualization layer usually and most typically is done in 3 dimensions. So the big aspect of a digital twin is the fact that you can see it from every single angle. Being able to see it from every single angle makes it more interesting, one, usable, two, and can drive a lot of efficiency drivers. We are going to use a complex and a non-complex example throughout this whole thing. So we're going to do the best we can to refer to a complex example as an airport and a non-complex example as a chair. So for a complex example, if I have a one-to-one replica, size, shape, dimensions, visual accurate of a warehouse in 3 dimensions, I'm actually able to walk around and view that very, very quickly. I can scale this digital twin up or down as needed. So I could sit it on my tabletop, or I can blow it up so it's real size, real world size, and visualize the different information in it. So why is this important? Well, for something that's extremely large, being able to walk around a 100,000 square foot facility will take a significant amount of time. Okay, depending how fast someone walks, 20, 30 minutes, 45 minutes, up to an hour, depending on how many things they need to do. If I have a one-to-one copy of that, I can blow it down into small scale and just hit the highlights, right? I can click in, zoom into a specific section, or I can look at a different area and make my life a lot easier, making my life a lot more efficient. What I can do in an hour, I can do now in a minute to check these different things. So that's from the visualization aspect, from something that's extremely large. For something that's simple, our chair example, if I have a one-to-one digital twin, I can place that in my room. Okay, so I can see what that couch or would look like with a chair of the same color or a different color, right? The fact that I can place it in the space around me increases my retention of the knowledge. So for our chair example, what we're doing is we're increasing the likelihood that we understand what that's going to look like in our space, how it's going to look like in our space, and ultimately, excuse me, ultimately how it will stick in my mind. Right? Humans are spatially aware. They're spatially composable. They understand how things work in space. That's what makes us fantastic beings. So when we load up a 3D model of a chair and drop it in the space around us, we're going to remember what that chair looks like more accurately than if we're just scrolling through Instagram or an e-commerce page, right? Okay, so we have a one-to-one physical representation. We hit a couple different aspects of that, right? So the first one's dimension. It's dimensionally accurate, right? We know that a chair is X number of inches high and a warehouse is X number of feet. On the larger scale ones, if we have a dimensionally accurate 3D model, digital representation, digital twin, that's visual, I can blow up literally to scale this to be a one-to-one space. Well, I'm nowhere near the actual facility. I could be sitting at my desk here in Florida, go and remote in or pull a digital twin of a facility in New Jersey, set it on my tabletop and see what it looks like, or pull it up to real scale and measure a certain wall to make sure a piece of equipment fits there. Those are the things that you could do when you have a dimensionally accurate one. Now, the visual fidelity is the next step, right? So not only does this dimensionally represent the facility that I'm working with, but the visual accuracy of the digital twin is equally important, right? So for our chair example, it makes sense. We want the chair to look like the chair that we're going to purchase so we don't have to return it or whatever it may be like. Great, fantastic, very, very straightforward on something that's simple. But something that's a little bit more complex, like our warehouse or our airport, right? If we're putting in new signage or we're putting in a new set of doors, we want to see what those doors look like in the facility itself without ever having to bring those doors to that facility. Great. Now we understand a little bit deeper of why that visual fidelity is important. So the next portion of a digital twin is the data that we can get from it. In this case, our chair becomes a little bit more abstract. We're not going to get a lot of feedback data from a chair, but our warehouse and airport model still really, really is interesting. So our warehouse can have a full set of IoT enabled devices and machines and manufacturing equipment within that facility. Great. IoT, Internet of Things, different chips, different pieces of equipment have sensor valves, pressure gauges, usage gauges, right? Ability to detect if there's going to be something that wears out or how many cans this facility produces, right? That Internet of Things sensor group is then fed to a cloud database or an on-prem database, so on-premises or cloud on through in a Wi-Fi or 5G connection to the internet, and then is processed in the cloud. That data is equally important for these larger facilities. If I have this data, then I'm able to make it actionable data. So if I have data and I have a visual fidelity model that's interesting, I then can go into this digital twin maturity model. We can and have seen simpler things like chairs starting to get into the IoT game. Imagine this couch behind me and being able to see how many times each cushion was sat in with a very simple chip, right? And the softness and the depth that that seat gets versus the other ones or versus what it was originally. Those are the different things that you can start thinking of when you start progressing through smart furniture or a digital twin with a data layer, right? Everything underneath the sun can have a chip and IoT sensor added to it. Even these pictures that are up on the wall behind me, this giant one can very simply have an IoT sensor to detect how much sunlight it's getting and the likelihood that that sunlight is damaging this photo behind me. These things happen all the time, right? There is a lot of usage for IoT sensors within a facility, but also within a single individual object. Okay, so now we have a visualization layer, we have a data layer, we need to start talking about what digital twin maturation or maturity model looks like. So we're going to start at 1 and we're going to go all the way through 5. With that, I am actually going to swap screens here. All right, fantastic. So here we go. This is the digital twin maturation model. What that really means is that there is 5 different levels to digital twinning. Okay, digital twinning being able to, sorry about that, digital twinning being able to express and visualize itself as meaningful and impactful. I gotta move my face around here a little bit. Sorry about that, guys. Uh, so what that means is on a level 1, we have a dimensionally accurate, physically accurate, realistic digital representation of an asset, right? An asset is that warehouse or that chair, and then is able to have a set of data pieces that enable it to be a smart digital twin. So think of these things as being spatially aware, interactable, allow you to have some type of experience and collaboration with it. So, our warehouse example, the spatially aware aspect of the warehouse is that it's dimensionally accurate. It is enabled with a layer of data in those IoT sensors for interaction. I can click on a specific IoT sensor that's happening within this facility, drill into that information, see what's actually happening on that, and make and understand what it is. That also enables the experience of it. So as I go and interact with this, I have an experience and learning, and I'm getting information that's specific to this warehouse. I can do the same thing with chairs. Again, we're going to use, or same thing with an airport. Again, we'll keep bouncing back and forth between that simple and that slightly more complex one. When we think of collaboration, that's really where things get interesting. The ability to have multiple users within an experience or allow multiple users access to this digital twin is equally important, right? No individual is the smartest person on the face of the earth, and they understand everything on this underneath the sun. That's just not there yet. But this collaboration aspect is equally important. Can I pull in this information or this information so that others can see it and understand why it's important? And yes, you can do that in this virtual twin level 1. I have an accurate size, dimension, etc. Now, connected twin. Okay, now we're talking about real-time data monitoring, reporting, and IoT. Okay, so we used IoT example in the previous one, and that's fine. The integration of real-time data and monitoring and reporting within IoT is really what differentiates a virtual twin and a connected twin. So the virtual twin, yes, you may have IoT sensors. You may have to go get that data, and it may not be in real time. There may be a level of latency there. Maybe it's a minute. Maybe it's 15 minutes. Maybe it's an hour. Okay. In this connected twin, we're getting a real-time data stream from those IoT sensors. We're also getting a new layer that sits above the data layer. So in level 1, we're just getting the raw data. In level 2, we're getting monitor and reporting. This is where machine learning starts to impact that data layer. If I have a manufacturing facility for Coke cans that's in New Jersey, and I want to see how many cans are coming off the line, and knowing that a specific machine typically breaks down after 100,000 cans, my reporting and monitoring now will allow those IoT sensors to upload that data into the cloud or into an on-prem server. A machine learning model will start to monitor how many cans are created and report that out, and that is all done in near real time or real time, right? So that's the big difference between a virtual twin and a connected twin. Again, all underneath the umbrella of digital twins. In our simpler example, right, that's where we take our chair and we add an IoT sensor, and we know that a specific chair, after 2,000 times it's sat on, 10,000, 15,000 times that it's sat on, it starts to show wear in the leather. It's a good thing to know. Okay, so now we add a additional layer into layer 3, which is predictive twins. Predictive twins start to get interesting because we're adding more machine learning on top of this data. So now that we can leverage this data, we can create some predictive outcomes. So from this aspect, our manufacturing facility in New Jersey that's creating Coke cans has analytics that are related to it. Now it has a custom dashboard related to that digital twin where I can go and see all my different manufacturing items, how long they've been work and running, how many cans they've created, and it'll start to give me some decision assistance. Hey, this specific piece of machinery is approaching that 100,000 can mark. Well, because it's approaching that 100,000 can mark, we need to start thinking about some maintenance. We typically see maintenance at X number of cans that are creative. You should probably deploy a team to go and do this. Great. That's awesome. We were going to go do that anyway because we see it approaching 100,000 cans. But now my predictive twin is giving me the information that I need, running it through a machine learning system, and creating some prediction for it. Now, the interesting thing is when we get into level 4 for prescriptive twins. Now we're leveraging advanced modeling and real-time simulation for the potential of future scenarios, as well as the prescribed data from previously. So now we can start to simulate, what if we let this machine run from 100,000 to 150,000? What's the likelihood of breakdown? Okay, well, that machine learning that's adding in there is now starting to be more complex. It goes from analytical machine learning or really algorithmic in the previous ones, if X equals Y. Now we can start training that machine model to be more prescriptive in what it's doing. That's where we get intelligent recommendations. That's also where we get process optimization. We can start looking at all of these things and say, well, listen, instead of having a team go there every single Thursday to do repairs, they're actually going to go every other Thursday and hit other facilities on the other weeks. So we're actually making this process a lot easier. We're driving more efficiency. Those what if simulations can happen across the board. Again, if we use an airport model here, the predictive twin will not only know the number of flights that are coming in, but what if there's a delay in another airport? How is that going to affect my airport when it comes to planes? And then make recommendations of, hey, if this happens, you need to do X and Y. These are the ways to mitigate those responses. So there's a lot of different factors. That prescriptive twin that we're talking about here, it starts to take into account external data for the simulation as well. So the example we used just in our airport, right, is a failure or a weather event that happens at another airport facility, and how does that traffic impact our facility that we have a prescriptive twin for. So that's really, really important when we think of it in that way. The last one, level 5, this is the highest level, everything becomes autonomous. Now, instead of the human reviewing this information, whether it's a machine learning prediction or a simulation, the computer can actually, or the machine learning system, or the program, or the platform overall of this digital twin can actually go and make autonomous actions. It's going to say, we are going to schedule X maintenance for it. This is really when we get into more of the artificial intelligence aspect of things. Because we know that we have an increased order of product, we are going to schedule maintenance sooner so that we can get through that higher quantity of production without a breakdown. Or we're going to do rolling production maintenance during this process so we can run our systems 24/7. Those are the different types of things when you get into this level 5. That's really, really next generational when we think about it. It's really making decisions correctly and issuing automatic actions that are either human inferenced or human notified, right? The human in this aspect is just being notified of the actions that are actually going to be happening from the digital twin system. Now, the really interesting thing about this is that this is already happening. We see digital twins all across the U.S. and internationally, and they are actually being done at the level 1, 2, and 3, right? Level 4 and 5, they're starting to be ideated and starting to be developed, but we haven't seen a full-blown level 5 autonomous twin just yet, or at least one that's publicly talked about and referenced. This is a fantastic maturity model when it comes to digital twinning, but also it enables us to understand what the future looks like for not only ourselves but our smart homes and our smart chairs and the way that we travel. It'll quite literally affect every industry underneath the sun, from a digital twin of a retail store all the way through a digital twin of a cruise ship. Imagine if you will, your smart home and being a level 5 autonomous twin smartphone smart home, excuse me. The home in and of itself will know when and who and where people are coming over, because they can see into your calendar. They can change the temperature based the ambient temperature outside, and ultimately drive a better human experience when it comes to living in this smart home. So, a lot to kind of digest and go through there. What's really interesting about this autonomous digital twin maturation model is that we ultimately will see this continue to grow as a massive use case for industry. And it doesn't matter the industry, right? We use very, very simple ones, from furniture and home furnishing, couches and chairs, all the way through our, you know, highly complex, highly, you know, detailed and data oriented, IoT driven airport. So, because that, this is definitely a start for the future, something to keep in mind, something to look at as a potential for your business or your future career path. There's going to be a lot of things that change over time. There always are, but this is one of those that looks like it's going to be equally important, valuable, and meaningful. I appreciate you turning in. We're a little bit over 24 minutes. I appreciate you if you're following on Twitch or LinkedIn or YouTube. Appreciate the time. Make sure you hit that follow button. Follow me on social media, and we will talk about our next podcast soon. Start getting some guests rolling in. Again, I am Rob Pedrosino. Pleasure to meet all of you, and look forward to doing this